Okay, so we are going to learn some basic log rules, and a lot of times we're going to talk a lot about number 1. We're going to use number 1 a lot. We're going to use it to solve, and we're going to be using this. This is log base 10. This is what we're talking about, log base 10. Again, just like we learned before, that if it's not stated, then it is base 10. Kind of like if you don't see a 1, and it is a 1. These are just good basic rules for you to know that any base that equals 1 is always going to equal 0, no matter what this base is. It could be 10, it could be 450, it could be negative 7. If it's equal to 0, it's going to equal to 1. And the reason why that is any number to the 0 power is equal to 1. So that's what that says, even though it says b. So b is any number to the 0 power is equal to 1. Again, this one right here is saying that any number raised to the first power is itself. And that's true no matter what happens. So you may have seen that on the homework from yesterday, or the note sheet that we did yesterday. So get these notes in your notepad, and we're going to move on. Okay, so this is our first example, and we're going to be using log base 10 to help me to solve this. When we get to this, I have no idea what 2 times some number to equal 21. Like, it's not one of those easy ones that we learned yesterday. So here's what we're going to do. We are going to use log base 10. We're going to use that rule 1. So I'm putting the 10 there so you can see it, but you don't necessarily need to write it. So I'm going to take log base 10 of 5, so of this side, and if I do that on this side, then I need to do it to that side. Then, because of that step rule, we learned that if it's to this power, we actually can throw it right out front, right there. So that's what happened right here. It got thrown right out front. So now I have 2x times some number equals a number. Because log base 10 of 21 is just a number. I just don't know what that number is. It's a really small number, but it's a number nonetheless. You'll get a decimal if you put it in your calculator. Then I'm going to solve it. So I need to get this 2x by itself, so I'm going to divide both sides by log base 10, or log base 10 of 5. So if I do that to one side, I need to do it to the other, and that's where I got here. So this is what I did. Whoops, my line didn't show up. Log base 10 of 5 on both sides. I don't really need to write the base 10. Okay, and then the next step that I'm going to do is I've got to get that x by itself, so I'm going to divide both sides by 2, and then I'm going to divide by both sides by 2. And if we type this into Desmos exactly the way we see it, you don't necessarily need the 10. You don't need the 10. You could just write log in Desmos, and I can show you that right now. So I'm going to type all that out. So if I type that into my Desmos calculator, I do get the same answer. So if we go back, oops. And that is what we got. We typically are going to want to round to the 4th decimal place. So you're going to want to do that to the 10th thousandths right there. All right, so let's do another one, a little bit more simple. All right, so we have 7a is equal to 41. Well, I'm going to use that same step. So I'm going to do log of 7 to the a is equal to log of 41. Well, now I'm going to use that rule and throw that out front. So I have a times log of 7 is equal to log of 41. Then I'm going to divide both sides by log of 7. Oops, I don't know how to write equals. And then I'm going to get a is equal to, and we're going to have to type that in our calculator. So let's do that. So when I type that in, I get a is equal to 1.9084. So we're going to go ahead and put that in our answer. So I get a is equal to 1.9084. Alright, and so now we're going to do our next one. Alright, so this one's a little bit more complicated. We've got some extra moving pieces. So again, we learned yesterday that we want to isolate our log or our exponent. So I want to isolate. So I'm going to add 1 to both sides. And I get negative 6 times 19 to the p is equal to negative 29. Then I want to divide both sides by 6. And I end up with 19 to the p is equal to, I think, just 29 over 6. I don't think that that simplifies any further. So then I'm going to now use my log rules, and I'm going to find log base 10 of 19 to the p is equal to log base 10 of 29 over 6. And then I'm going to use that rule, throw that right out front. Oops, I don't know why I put a 9. Let's delete that. Oh man, deleted everything. Okay, so I fixed it, and we go ahead and we have this. We have p times log 19 is equal to log of 29 over 6. So we're going to get that p by itself, and we're going to divide by log 19. Divide by log 19. And if I type that in my calculator, I end up with p is equal to, so p will be equal to log 29 over 6 over log 19, or 0.5351. That will be my answer. Okay, so this is why we're learning this. So we are going to get some practice with this, but this is what we're going to do. So now we have some weird numbers. We're going to solve for t. We're solving for time, and we've been solving for time before in simple interest, but we haven't done it with compound interest. And time is an exponent, so we're going to need logs. It says to leave our terms in our answers in terms of logs, so we're going to do that. So I have this times some unknown. So what I'm going to do is I'm going to divide both sides by 4,800. That becomes a 1. And I'm going to divide by 4,800. Okay, so, oh no, go back. So then I actually end up with, this turns into 1.14375. I'm going to go ahead and leave it that way. It's going to be equal to 1.0009 to the 3t. Okay, now I'm going to use that log rule, because now I've got my exponent, I've got my exponential isolated, so I'm going to find log of 1.14375. It's going to be equal to log 1.009 to the 3t, and I'm going to throw that out front, and I get log 1.14375 is equal to 3t of log 1.009. Okay, so now we got to the part where we can deal with this. I need to get that 3t by itself. So I'm going to divide both sides by log 1.009. Log 0.009. And then I am going to end up with log of 1.14375 over log 1.009 is equal to 3t. Well, to get that t by itself, I'm going to divide by 3, and I'm going to figure out what that is. So I'm going to hit pause, and we're going to go to Desmos. Okay, so I've typed in log 1.1375 divided by log 1.009 over 3, and I get about 4.793. 4.793. Let's go back to our presentation, and so we can write our answer. So then I get that my time, where is it? Okay, time is equal to 4.7, what did I say, 793? Or time is about 5 years. Just going to round to the nearest year. I would accept both answers. You could round this 4.8 years. That would be fine. But this is why we were learning logs. So we are going to get some practice on that, and you should see it. So thank you so much. If you have any questions, let me know. Ask me in class. You can send me an email. You can put a note. Let me know. One more thing. It does say leave your answer in terms of a logarithm. So your answer would be this right here. That your final, if you were to leave it in logarithmic form, you would say, why isn't it letting me? Thank you. So then we would say that t is equal to what we solved over all over 3. I would prefer these answers. So I will let you know to give me your answers in terms of years. All right. Thank you so much. I just wanted to clarify.